into steam. Or it might be an insulation leak where some rainwater from in the ground seeps in to touch the 235 outside temperature of the pipe, in which case it turns to steam. So in either case, if you see steam coming out, that means there's a heat loss somehow or other. Bad news. Oh, and they burn fuel in it. They mix fuel and air together and burn it here, and then it comes out here as products of combustion, which is mainly carbon dioxide, and there's excess air more than likely, and leftover and nitrogen that just goes through for the fun of it. Oh, it was made in Richmond, Virginia, the English boiler. That's called boiler number 3 that was made in English, I think. And there's a total of 3 boilers down there. All right, temperature control. They measure the temperature of this hot water, send that information to a temperature recording controller, which we'll see. That sends information to a temperature control valve, which is actually 2 valves, one to control how much fuel goes in, and one to control how much air goes in, to keep those more or less same ratio. You add more fuel, you want to add more air. There's a long word that tells what that ratio should be. Do you know what that word is, Ashley? Huh?
What is it?
Starts with an S. Long word. Stoichiometric ratio. You knew that, didn't you? Here is the cooling tower. It cools by taking cooling water return from the air conditioning unit, 80 degrees, drops it into the cooling tower, and 5 of you will be able to go up on top of the cooling tower. Used to have the whole class up there, but they got excited about Homeland Security or something, and they only let 5 of you at a time. Oh no, they're worried about it falling over. So only 5 of you can go to the top of the side. And there's a fan on top that pulls the air out, so there's dry air, relatively speaking, dry air going in the side of the cooling tower and going up. And when the hot air comes in contact with the dry air, it evaporates. When water evaporates, it takes heat, so the leftover water cools, and it drops down into a basin on the bottom. How many of you ever stepped out of a shower and thought, ooh, it's cold in here? 1. So that's because, not that necessarily it's cold, but the water that's on your skin is evaporating, and it takes the heat from your skin in order to evaporate, because it wants to evaporate. Guess what? There's a control system on here. Measure the temperature of this water, send it to a controller, which sends it to a action motor, a motor that turns on or turns off this fan or makes it go high speed or low speed. How big do you suppose these fans are? Yay big? Bigger than this?
Bigger than a Honda.
What?
Bigger than a Honda.
Bigger than a Honda, you're right. They're very large. They're probably 10-foot diameter, I'm guessing. Maybe more. Oh, this picture of a student from another semester actually climbing up there and looking over into the big, the thing where the fan is. What do you call it? Shroud. The shroud that the fans are. Now, don't tell anybody down in the plant that you've ever seen anybody do anything like that. Oh, and while we're there, we'll see this old archaic thing. This is a control valve. So it might still be down there, but I'm not sure. But this used to be in the middle of a pipe, water pipe or something like that. And you know how a valve works. There's a thing that comes up and down. If you turn a valve, it lifts something up or pushes it down. Well, this is the bar that's connected to that thing that goes up and down. And that bar goes into this thing here, goes up here, and there's a thing called a bonnet here. Anybody know why it's called a bonnet? Because it looks like a bonnet and it's on top, so it looks like a valvette is wearing a, oh, here's the bottom part. So here's where the action takes place. And the bonnet has a top part and a bottom part. And between the two is a rubber diaphragm. And it's got a connection at the top where you can put air pressure, or a connection at the bottom where you can put air pressure. And if the pressure on the top is higher than the pressure on the bottom, it pushes the valve closed. And if it's the other way around, if the pressure on the bottom is higher than the pressure on the top, the diaphragm moves up, and it's connected to that stem. I left that part off. The stem is connected to something right on the diaphragm, so if the diaphragm goes up, the stem goes up. The diaphragm goes down, the stem goes down. So that's a air-operated control valve. They are so old-fashioned, but you might run into one sometime. Nowadays, they're all electronic, and we'll see some of those too. This is history lesson. Now, you can put the control air on top, in which case it's called air to close because you increase the air pressure when it closes it. Or you can put the control air on the bottom, in which case it's called air to open, which case the thing opens the valve by pushing up. So, which one's better, air to open or air to close?
Depends on where you are in the system.
Well, that's an excellent answer. It depends on where you are in the system. Give me an example.
You may be in a situation where if that valve were to fail, you need it to be closed versus being open, like say in a nuclear reactor.
Oh, a nuclear reactor, they have control systems?
Yes, sir.
Surely they're stable, right? Surely they don't oscillate all the time. I hope. We'll find out more about that later, but anyhow, you're right. So let's say in our plant down there, the valve that controls the fuel going to the boiler, probably if the valve fails, if the air compressor system fails, if the power goes out, they want the valve to automatically close. And inside this area here, there's springs to make it close, if that's the case, to push it down if all the air fails. Another case, in cooling water, you might want it to be wide open when power fails, in which case there's a spring to push it up, so that if the air pressure fails, it pushes up. Those are called failed closed or failed open. So you get all sorts of nomenclature here. What's AC mean?
Air conditioner.
Air to close. What's AO mean? Air to open, good. What's FC mean? Failed closed. What's FO mean? What's FU mean, students? See, ultimate frequency. I'll just check and see if you're moving. I think that's all. All right, so what